Welcome to Chapter 2. We're starting with Section 2.1, Linear and Quadratic Functions and Modeling.
This chapter guaranteed to mess you up a little bit, so you want to make sure that you...
Why would you start off that way?
Well, because they need to be warned.
Okay, this is your warning. I don't think that that's true. But...
Baby steps and you'll be perfect.
Okay, we're starting off with the definition of a polynomial function. You've got all of this math jibber-jabber here, which is basically telling us that if we have a polynomial function of degree n, we've got the leading coefficient there is a of n, which is good.
Writing a polynomial.
Oh, you're writing a polynomial.
I'm just going to, for example.
Here's an example of a polynomial function that you might see in your day-to-day life. I think there's also maybe some examples on the next slide.
Nice.
Don't get too carried away.
I won't.
Okay, so there's a polynomial. Like most things like you've done so far have been polynomials in like Algebra 2. So the key to a polynomial function is the exponents of your x's have to be 0 or larger.
Integers?
Integers, yes. Integers that are 0 or larger. So that -1 there, how does that have an exponent of 0 or larger?
It's really cool. This guy is a super secret one. He is x to the 0 power.
Because anything to the 0 power is 1.
Your dead grandma to the 0 power?
I don't have a dead grandma.
I do.
That's awkward. All right, so we have a basic definition of polynomial functions. Example 1 asks us to determine which of the following things we've got here are polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So f of x equals 2x squared minus 3 plus x to the 5th. Is that a polynomial function?
The secret is in the exponent. So do these meet the requirements from the previous slide? I think they do.
They do, because they are integers, they are 0 or greater, and really you can just ignore the -3. Anytime you have a number, the number is going to be fine. A number is a polynomial. So the other exponents work out, so that is a polynomial. Let's talk about degree. The degree of the polynomial is the biggest exponent.
Just a quick reminder.
Yeah, that's why this is a polynomial. Okay, the degree of a polynomial is the biggest exponent. Yeah, yes, the biggest exponent is what?
The biggest exponent in this case is fever right there.
So the degree of this polynomial is 5. Then we also need the leading coefficient. The leading coefficient is the coefficient that's in front of wherever we got the degree from. We got the degree from where he circled in green. And so what's in front of x to the 5th? Well, nothing, but actually there's a 1 there.
How many x to the 5ths do you have?
I have 1. LC stands for leading coefficient there.
That is correct.
Okay, so there it is a polynomial, degree of 5, leading coefficient of 1. G of x equals 4x to the -2 plus 3. Is that a polynomial?
The evidence is right here inside the exponents.
We cannot have a negative exponent and have it be a polynomial function.
I say shenanigans.
No, really, that's the way it works.
No, shenanigans, not a polynomial.
Okay, not a polynomial.
It's shenanigans as in not a polynomial.
Okay.
Not a poly. It doesn't want a cracker. I'll be here all year.
Yes, you will. And the reason is because of the negative exponent.
-2 is not bigger than 0 or an integer bigger than 0.
Yes.
It's not bigger than 0.
It's not
Fails the
bigger
first
than 0.
guy.
Fails it. Okay. H of x equals 9. Is that a polynomial? Well, we kind of actually said a couple of times already how this whole there just being a number thing works. It's really like there's an x to the 0 next to it. So that's got an exponent that's 0 or larger, an integer 0 or larger. So that is a polynomial.
Let me get the right color here. So polynomial. It does want a cracker. Poly wants a cracker.
Okay. Because poly only eats 0 or larger integers.
That is correct.
There you go. And so our degree is the exponent we have there, which is 0. So the degree of 0. And its leading coefficient then is what's in front of our x to the 0, which is 9. Example 1 done. The first thing we're going to talk about specifically as far as polynomials go is a very specific type of polynomial function called a linear function. It is a polynomial function of degree 1, and it has the form up there. It says f of x equals ax plus b, where a and b are constants, and a does not equal 0. You may be more familiar with it as being y equals mx plus b. That's saying the same thing. Point slope form, which he just drew an arrow to, is like the most important formula, I would say, in the world.
I mean, if you can do point slope formula, you can do anything, but you can't do like slope intercept. Like, that's only good for slope intercept. Point
Right.
slope,
Point slope is the best way to go.
you're going to use it in conic sections, which is going to be in the spring. You're going to use it with any parent function that you investigate. It's going to be all over trig.
Yeah, it's just all the time.
It's
Point
there.
slope. Let's
Yeah.
use it. So what that formula looks like is it has a y and an x that just stay as y and x. It has m, which is the slope of the line, and then you have to have a point, which is the x1, y1. And you plug in the slope, x1 and y1, and then that's your equation of your line. And for the purposes, especially of the AP Calc test, there is no reason to simplify that into slope-intercept form.
No reason at all.
You could if you wanted to.
But you make a mistake and you're toast.
Yeah, so we would like for you to just leave it as point-slope form. And they were crafty with the name. There's a point and the slope, and it's right there, and it's called point-slope
Some
form.
genius did that and has earned thousands of dollars.
I seriously doubt that.
Well, maybe.
Maybe Mr. Point or Mr. Slope could tell us otherwise.
Well, it's like the one guy proved that if you have 6 pigeonholes and 7 pigeons, that one of the pigeonholes has 2 pigeons in it. And he got paid a ton of money to do that. So I'm
What
just saying
if
it's
you-
possible.
I don't know where that came from. Example 2. This is exactly like some of the problems in our assignment. So write an equation for the linear function f satisfying the given conditions. The way they wrote this is weird. They are telling us about 2 points because f of x means that what's in the parentheses is what x is. So we have a point for this first one. That would be -3, 4.
Sorry, -3, 4.
-3, 4 is our first point that we get from f of -3 equals 4. And then our second point would be 3, 6, because we have f of 3 equals 6. Now we need to find the slope, and then we need to plug into point slope. So I didn't put the slope formula on there. Maybe we should put that
You know,
somewhere.
here's what you do. You stack your points up like this and you just subtract them.
Oh, well, that's one way of doing it.
How about that? And then,
And then
you
you
do
put
you do
y
y
over
first.
x.
So you're going to do 4 minus 6 over -3 minus 3. Order is taken care of. Nothing gets out of whack. Everything's appropriate. Sign is good. So I have -2 over -6, which I believe is 1/3.
That's right, because the negatives cancel each other out. You divide by 2 on the top and bottom, so that's 1/3. What if you wrote out the slope formula? Just in
If
case
I
somebody's
wrote out the slope
really-
formula,
really
one thing that
interested.
will super come in handy in calculus classes, if you just get into the habit of always going your stopping point minus your starting point, which would look something like this. y2 minus y1 divided by x2 minus x1,
And that's what he just did.
and that's your slope.
Okay, so that's our slope. We need to take that in one of our points and plug it into point slope formula. It
I
does-
choose this point.
Okay, let's choose that point. So that's -3, 4. That's our x1 and our y1. So we plug it in. Y minus y1, which is -4, which is 4, equals 1/3 times x minus a -3. Now, the minuses next to each other there, you might notice you do that thing that you learned a long time ago, ching chang, walla walla bing bang. That becomes +3. So there you go. That is the equation for the slope of this line. We could also, though.
Ching chang, walla walla, bing bang.
Yeah.
I like it.
Yeah. You don't. Isn't that how they learned it?
I think it's a click was how
Click
some of
click.
this,
I can't.
some of
I
the
couldn't
kids
remember it.
learned
Click
the
click, bang
click.
bang, bling bling, whatever. So if you were to solve this for y, why are you? We don't have to. Why are you solving?
You
for
know,
y?
some kids just they're real OCD about how they like their problems to look. So you know.
If you wanted to solve for y, you have to add the 4 over. You have to distribute the 1/3.
No, you don't have to. You could leave it like
Oh.
this.
Well, okay.
I think both
Okay.
of those are good.
Okay.
You know, some kids just like to have a y all alone.
Okay. We need to graph it.
Right, well, I'm out of space.
Up there in the right
Okay,
corner.
up here, right corner. So I'm going to graph the point negative 3, 4.
Negative 3, 4.
Negative 3, 4. There's my point. My slope is down 1, forward 3, or I could just plot the other point.
Don't you mean up?
That's
1,
what I
over
said.
3?
Yeah.
Or
So
you could just plot the other point and draw the line that goes between them.
3, 6. And I'm going to connect those suckers with a straight line.
Straight-ish.
Okay, so hold on.
It's okay. Don't worry about it. There it is. There's the point.
There we go.
Good to
Right through.
So
Perfect.
there's actually more than one answer to this, though, right? Because they could have used the other point.
They could have.
So you could have gotten y minus 6 equals 1/3 times x minus 3, and then that would be from the other point.
Exactly.
All right. Quadratic functions and their graphs. The first thing you need to know is a quadratic function is a polynomial function of degree 2. Its graph is a parabola. The standard form for a quadratic function is given up there. F of x equals ax squared plus bx plus c. That should look familiar because that's what we use when we're doing like the quadratic formula and stuff like that. Vertex formula. Either the lowest point or the highest point of your parabola, that's the vertex, depending on if it opens up or opens down. If it opens up, it's the lowest point. If it opens down, it's the highest point.
Yep.
And so the way you can find that from standard form is this little formula we've got, negative b over 2a. You find that, and then you plug it into your function, and that gives you f of negative b over 2a. Or sometimes they give it to us in vertex form, which looks a little different. It's down there, right there.
And anytime you can work straight out of vertex form, that's always easiest with parabolas.
Yeah.
Like every time.
Don't like try to FOIL it out and multiply and stuff, because it actually is easier. Because the vertex of that form is h comma k. Like whatever's inside, you do the opposite of. Whatever's outside, you leave alone. Just like when we talked about transformations and something.
Yes. The super secret opposite society is in
Super
full
secret opposite society.
bloom inside parentheses.
Yes.
Anytime you're inside parentheses.
Anytime you're in parentheses, you change the sign. So that negative h, it becomes positive h for our vertex, and the k on the outside continues to be positive k.
That's correct.
The axis of symmetry, depending on which way you found your vertex, it's the x value. X equals whatever. It'll either be negative b over 2a if you found the vertex that way, or it'll be h if it's already in vertex form. Right? It'll be x
Right.
equals h.
Yeah,
It's
sure.
a symmetry. If it's in vertex form, the axis of symmetry is x equals h.
And if,
Are you going to write that?
yeah, sorry.
So it depends on how you found your vertex as to which of those two things you would use. So why don't we draw a parabola and just point out like
I know what
we're
this looks
talking
like.
about.
No mocking my skills.
Y equals x squared.
Well, the scale there is a little tricky. It's hard to
I'm
figure
paying
out.
attention, I'm paying attention. Oh, wow, this is way up. I'm just going to go with right here.
That kind of looks like a B.
Yeah, I'm going to curve it at the bottom. It'll be, it's going to work. It's going to work really bad. No mocking, Mrs. Stevenson.
We all know that
Artwork.
this is a parabola, so it'll be okay.
So this y equals x squared is what he's graphing right now. If there is a positive in front of your x squared, it is a parabola that opens up, which means that the very bottom point is your vertex. And so since we didn't have anything being added to either our x in parentheses or outside of parentheses, our vertex form, it's kind of in vertex form because our vertex is at 0, 0.
Yep, x plus 0 is x.
Yeah, and so then we could talk about the axis of symmetry being the line x equals 0, the line that is vertical that goes through 0. And what we mean by axis of symmetry is that's where if you fold it, hot dog style, it looks the same on either side.
Mirror image, except for this one, which of course is not perfect. We've all had a chuckle. Let's move on.
Okay. If we were to graph y equals negative x squared, what changes?
I'm just going to freehand this one because it'll be better.
That is so much better free-handed. That's amazing. Where was that before?
I was saving it up for later.
The negative, if we remember back to our transformation rules, it's not inside the parentheses, and so this is a reflection over the x-axis. And so that just means if you see a negative in front of the x squared, that means that it is a parabola pointing down. And so our axis of symmetry, since we didn't move left or right, is still at x equals 0?
Yep.
Yep. What about that crazy thing down there? Y equals 2 times x minus 2 squared plus 1.
The super secret opposite society is now kicking in, so that means my vertex is going to slide to the right 2 times. So
Yes.
he is now going to, let me get a little bit of a color difference here.
Okay.
And so here's my new vertex.
What about up 1?
Well, and then I hadn't got there yet.
Oh,
so
okay.
I slide to the left, slide to the right 2
Slide
times,
to the
and
right
then pass the
twice.
duchy up once.
What did you just say?
You know that one song? Pass the duchy to the left one time.
And then vertically stretch by 2.
So instead of coming over here to my, to 3 and going up to 9, I'm going to go up to that times 2.
Right.
Yeah. So
It times your
yeah, it
times your y values by 2.
So I can't even put that on this graph.
Okay.
But it's really thin. I'm going to freehand this again. This is going to be totally great.
So
Actually, let's see.
While he's freehanding this,
0.
or whatever, the important thing is that our vertex was at 2, 1, so that's now our bottommost point. If we were comparing this to the graph of like y equals x squared, we know that it's thinner because we're vertically stretching by 2. All of our y values end up being doubled, and if you're trying to make this accurate, like vertically stretch it first and then move it is the easiest way to do it, in my opinion. I'm not even paying attention to what you're doing. And since it's a positive 2 in front, remember that means it opens up. If it had been a negative 2 in front, it would open down.
I feel like I grabbed something wrong here. 0 minus 2 squared is 4 times 2 is 8 plus 1 is 9.
9.
Okay, so it's 0, 9. And by axis of symmetry, if I'm at 0, 9, guess what? Over here at 4, I'm at 9. And so here is my graph. Almost. Yet again.
I got to quit putting points down.
Since our vertex was 2, 1, our axis of symmetry would be the line x equals 2, because the axis of symmetry just takes your x value from your vertex right there at x equals 2. So there's our quadratic functions.
Okay, so we're going to look at, did you want to go?
No, go.
No, I'm going first. Okay, so we want to look at the vertex and axis of the graph of f of x equals 5 times x minus 1 squared minus 7. And it's not hard.
No, because this is in vertex form, which we can tell because of the parentheses and the squared and whatnot.
We love vertex form. And remember, inside those parentheses is the super secret opposite society. So instead of having -1, our vertex is actually going to have an x-coordinate of 1. And a y-coordinate of -7, because the people outside the parentheses just aren't as cool.
So V for vertex. The
V.
vertex of this is 1, -7. Whenever it says axis of the graph, it's talking about the axis of symmetry, not some other random axis.
The x-coordinate of the vertex.
And it's always going to be x equals, not always. In this chapter, it will always be x equals the x-coordinate, which was 1.
Yep.
Ta-da!
That's all there is to it. Piece of cake. Well, what about another one, you might ask? What about one where it's not in vertex form, you might ask? Well,
That formula, negative b over 2a, we could use that.
we can, but you have to know the a, b's, and c's here.
It goes in order if your function is in order. X squared x and then your number, it goes in order. A, B, C, do, re, mi, it goes in order.
Do, re,
Like in the sound of
do,
music.
a deer,
Exactly.
a female. Okay. So
Negative b over 2a is what we want to find.
the opposite of -2 is 2, for those of you scoring at home.
Over 2 times a, so 2 times 4. 2 over 2 times 4, well, our 2's would cancel, and that would just be 1/4.
And if you don't cancel your 2's, you're going to have 2 over 8, which reduces
Also,
to 1/4.
yeah, it's
so
also
all the
1/4.
same.
So now, that's the x value of our vertex. If we plug that into our function, so plug in a 1/4, that'll tell us the y value.
You could get a fraction. Life is loaded with those. So if you're working on a problem in your textbook or some other place, and you get a fraction value, don't automatically panic. We are in big school now where fractions do show up quite frequently.
As my graduate professors like to say, we're big kids. We can handle fractions.
And some of you guys have had it pounded into your heads that decimals are the way to go, and I will agree that
Who
there
in
are
the
times
world
when...
would say that?
Well, there are those that are there. By all means, use a decimal. However, on the non-calculator part of this test, you will want to use fractions because 1/2 times 1/2 is easier to do quick than 0.5 times 0.5. So Mrs. Stevenson is grinding out a problem for us right now.
I think we need some common denominators. So common denominator of 4. So times 2
Yep.
times 2
And a 6.
times 4 times 4. So that's 1/4 minus 2/4 plus 24/4, which is 23/4.
23/4.
That's the y value. So our vertex is 1/4, comma 23/4. Now that seemed like a lot of work. Mostly though, that was because it was a
Fractions.
fraction. If we'd had a normal set of numbers, that would not have taken as long. That's the vertex.
Axis of symmetry.
Will be x equals our x value. And it asks us to rewrite the equation for the function in vertex form. So I'm pretty sure that this is how this works. We take the number that's in front of our x squared, stick that on the outside, then we plug in our vertex. That'll be x minus 1/4 because it's inside the parentheses. And then on the outside, we've got 23/4. That should be right, right?
I mean, I think that's how it should go.
Yeah, so
You
there
can
we go.
always graph it and see.
let us know.
Your good buddy completing the square makes an appearance now, and he's really, really super handy,
He is.
especially when you want to get into vertex form.
He can be hard to get along with sometimes. He can make your life a little difficult, but you just have to know how to deal with him, and then everything's fine.
Yeah.
So let's talk about it. Let's do completing the square.
Let's deal with it. And I like to refer to completing the square as one of my good German buddies that I used to teach with way back in the day, Dr. Hoffen squared. Because ultimately what you're going to end up doing is taking Hoff and squaring it. So one of the things that helps the kids is the German reference part.
I see.
Hoffen
So
squared.
what you need to do is realize that by completing the square, we're trying to come up with something to stick in this blank so that we can factor this into the same thing twice, which is going to let us put a squared. And then we're going to end up with stuff on the outside as well. So we're trying to figure out what can I put here so that it factors evenly. And that's where Professor Hoffen square comes in.
Dr. Hoffen squared.
You always take this number 14, the number in front of x, you take 14 and you half it,
Hoff it.
and then you square it.
Hoffen squared.
So what we would put here is a plus 49. Now, am I just allowed to add stuff randomly to equations? Is
I'm
that
pretty
cool?
sure we have to follow rule number 72 of Algebra 1.
Which is that if I add something to one side of the equation, I need to also subtract it from that same side. Like
Yes.
somehow I have to keep it balanced. And so I can't just add 49, I also need to subtract 49. So we're going to stick that out here. Okay, I added 49, but I also subtracted 49. Together, those are 0, so I didn't
Nothing's
break the
different,
laws
nothing's
of
different.
math.
And this is mistake number 4,372. It can show up quite frequently if you're not careful.
Right. So if I wanted to factor x squared plus 14x plus 49, I would have to say, well, what multiplies together to get 49 that adds to give me 14?
I would say 7.
7 and 7, right?
Yeah.
So that's how we're allowed to put it as one parentheses with the squared, because we're saying that this top part factors into x plus 7 times x plus 7, which is x plus 7 squared.
You might notice that that 7 is also what we got half of.
Right, this number right here, this 7, should always end up being that 7 over there, which will save you some work if you remember that. We also need to come over here and figure out what 51 minus 49 is.
I know that one.
Yeah,
73.
plus 2.
Okay, that was my second guess.
Yeah, so we've completed the square. Our function in vertex form is, in parentheses, x plus 7 squared plus 2. And then we can describe the graph of that function because this is a graph that we've shifted
7 units to the left and 2 units up. Pick the pen up, Mrs. Stevenson. Yikes.
Okay, thanks. Yes. Shift left 7, shift up 2. So let's...
Hey, by the way, let's just, for kicks and giggles, the axis of symmetry on this one, could we identify that?
I believe that would be the x value of the vertex. So what is the vertex of this? We have to take the opposite of what's inside the parentheses, and we don't take the opposite of what's outside. So that means x would equal -7.
That's just pretty cool.
That is pretty cool. Are we done with this part?
Yeah, let's do the next one.
Okay, so obviously we can get more complicated with completing the square. It can't always be that simple.
If only.
What if we have a 2 here in front of our x squared? That's not going to work out. What we need to do is we need to say, okay.
Well, here's what we need to do. Dr. Hoffen squared is single.
Dr. Hoffen squared is single.
He only shows up around single folks. He is
single x squared.
Single x squared.
Not double x
He
squareds.
is not one to fly more than with just one x squared. So
that's good.
yeah. So whatever is in front of the x squared has to be factored out so that we only have a single for Dr. Hoffen squared.
What we're going to do is we're going to factor it out of these two terms that have x's, not the -19, which is convenient since -19 is not even. So if I factor out that 2, I get x squared plus 4x, and then I'm going to leave my blank because that's where completing the square is going to happen. And then the -19 is out here. And we're also going to have something that ends up there, just like in the last problem.
Rule number 75. Got to add and subtract at the same time on one side of an equation.
Okay, so we need to figure out what to put in here. We do that using this number in front of x. We do the Hoffen squared.
Hoffen, yep. We're going to take Hoff,
Take Hoff.
square it.
And square it, which gives us 4. So if I add 4, we need to realize that what are we really adding if we add 4?
2 times 4.
2 times 4, which is 8. So
Last
out
check.
here, we need to subtract 8.
Brilliant.
Okay? And that's because this is not really a 4 that we just added because we stuck it in the parentheses. We have to do 2 times 4 and get that 8. We really added 8, so we're subtracting 8. That's like the biggest hang up with these kind of completed
It's a mistake that is easy to make until you kind of get comfortable with it.
So easy. So 2 times, we can factor this x squared plus 4x plus 4 into x plus 2 squared. -19 minus 8 is minus
27.
27.
Got that one right. I'm
Yeah.
on that.
So-
Hey, and there we are in vertex form. Now, I prefer vertex form myself because when I look at a vertex form of a quadratic equation, I know exactly where I'm at.
Exactly.
It's difficult to see exactly what my graph is going to be doing when it's just in that general x squared plus x minus a number form. So if we're really wanting to dig into a quadratic equation and check it out, always take the time to complete the square. Nice dig. Or you could be like volleyball dig.
Oh, okay. Yeah.
So anyway, but it always gives you an opportunity to see exactly where you need to go.
So we would shift left 2, down
Going down,
27, and then that 2 in the front, that's a vertical stretch of 2.
vertical stretch.
The way we do these problems, we are not really going to have to deal with horizontal stretches and shrinks because we want the 2 to be on the outside. We
That
just
is correct.
completed the square. So, vertical stretch of 2.
Fabulous. Okay, so we're going to write an equation of a quadratic function, and oh, by the way, it's got to go through these 2 points, one of them being the vertex. So, impossible, you might ask?
Definitely not impossible. This is quite possible because remember how we have that general vertex form from a previous slide?
General vertex form is so handy.
Well, the vertex is HK, right? And
No way.
They told us what the vertex was. It's HK. This point over here, now wouldn't that be considered an XY situation?
That would be. And here's the thing that the teenage brain struggles with. When they give you a point, they are literally giving you a value for X and a value for Y. And for whatever reason, sometimes that old teenage brain with pumpkin bread recipes and song lyrics and football plays.
You're really starting to get disconnected.
Yeah, but it messes it all up. So
you know, when they're watching this, you'll be 40.
You're right. I will be.
You're a little
And
disconnected.
some gray hair right there.
Okay. Anyway, so we're going to put in, remember y and f of x are the same. So we're going to plug in h, k, x, and y so that we can figure out what a needs to be.
And we have all those. Remember, f of x is actually your y coordinate. Gray hair.
Minus a -2. And did I get everything in right? Is that all the way it's supposed to be?
-27 and -4. I believe so.
Okay,
Yep.
so we just plugged in h, k, x, and y. And so here inside my parentheses, remember we got ching chang walla walla bing bang. Those are going to be pluses.
I like that.
Let's go ahead and let's add this 5 over.
Whoa, slow down, crazy woman, with these math skills.
Let's ignore that. -27 plus 5 is -22.
You realize for all the OCD kids, you just created a point of reference that they will not be able to get over.
Oh, they'll be fine.
Okay, that's
-4
what I say.
plus 2 is -2.
Squared.
Squared. Don't forget to square it. Squaring's important.
And when you punch it into your calculator, you know, because somebody's going to do this, -2 squared is not -4.
No, it's +4.
Totally
'cause
+4.
You have to put it in parentheses and square it.
Yeah.
So -22 divided by 4, we can
11 over
simplify
2.
to -11 over 2.
Hey, a fraction.
That's okay. We don't mind fractions. So let's write this equation. F of x equals, we just figured out a is -11/2. Now we want our x to be in there. X minus our h value, which was -2, so that's +2 squared. And then on the outside,
-5.
So when you go back to write it, you do put in the vertex and you put in the a that you just found.
You need to leave your x and y alone when you rewrite the function for real, because we're trying to locate all the possible x and y's. We're not looking for just one specific anymore.
Yep. Linear correlation and modeling. So whenever we have real life data, we a lot of times try to approximate some kind of linear model that goes with it. And so one of the things we have with that when we come up with a linear equation is this correlation coefficient R. And whenever we find like a line of best fit on our calculator, that's something it gives us is an R, which tells us how good of a correlation it is.
The
So-
closer to 1 or -1 your R value is, the stronger the correlation, with 1 and -1 being perfect fits.
Right. If it's a positive number, there's a positive linear correlation. If it's a negative number, it's a negative linear correlation. If it's close to 1, it's strong. Or -1, because it has absolute value there.
Right.
And then if the closer it gets to 0, the weaker. Or if it is like 0.00001 or something like that, there's basically no linear correlation.
None at all.
So we've got these pictures here as examples. Like, see how if I drew like a line of best fit here, which means the points are kind of equal on both sides, it's a line that approximates those values.
Like a linear straight line.
See how they would all be pretty close to that line? This is a strong positive linear correlation. But on this one, if I drew a line, then it would be like the points would not be as close. Like if I drew
Wow.
well, failure on my part of drawing a line. Now you
Draw
get to
a
make
good
fun of
line.
my lines. How
That
about-
line is the most amazing line
See
I
how
have
the
ever
points are
seen.
kind of far away on either side, so that's going to make it be a weak positive, but it's positive because it's going up and to the
Yeah,
right.
they generally trend up to the right.
Like, where would we draw this line? Like
No,
that? I
no.
mean, no, that's no correlation.
No,
That's
you
all
can't
kinda
draw
spread out.
all those lines on one
No.
graph.
So that's terrible, but that's negative and strong. This would be negative and weak.
And when you're using your calculator to find these different points of correlations, it will give you an R value when you perform the math on your calculator. So you don't have to try and figure that up on your own. That's
No,
not one we're going
no.
to say like, hey, determine the R value.
You just write it down from your calculator.
You just write it down from your calculator.
Bingo.
And we'll have a slide, like when we do work out an example, we'll show you how to use your calculator to find those correlation
I believe
coefficients.
just in a moment, the next video they watch.
Shut the front door.
No, I will not.
Get out of town.
I also will not. Example 7. Draw a scatter plot of the data. Describe the strength and direction of the correlation between subscribers and average local monthly bill. So because it just asks us to look at the correlation between subscribers and average local monthly bill, we're just going to plot those two parts of our table.
Not using the years for
Yeah.
this particular question because they aren't asking about time at all.
Yeah. So that means that subscribers will be the X and average local monthly bill will be the Y.
I believe that is correct.
There it is, X and Y.
Yep.
So
Just like we said.
just like we said. So to draw a scatter plot, we've got like a little L shape here. We need to make some sort of scale. So put some tick marks on there, and then we'll have to figure out what to make our tick marks.
A comfortable amount. We want to be able to see everything from 69 to 158 on the x-axis.
Yeah, on the x-axis.
On the y-axis, we'll want to see everything from 39 to 49. So the scale just might be a little different on x and y.
And that's okay. Only whenever you really need to see like a 1-to-1 change do you really need to have that scale be the same.
If we just need a general idea of an equation, don't necessarily need the scales to match at all.
Yeah, so we picked to go up by 20 starting at 60 for the x, but for the y's, we're going to start at 35 and go up by 5s. And then you just have to plot each of those points. We'll also show you how to do this as we speak, showing you how to do this on the
It's going on the calculator.
How to
We
plug it
are
in.
that good. Look,
Yeah.
look, no hands, no
but
hands.
there's
Calculator.
writing on the screen,
Mhm.
and there's calculating. Are there going to be two calculators? One
There
for the
will be,
84,
yes.
one for the
Yes, you can
Inspire?
see both right now. That's a
Yeah.
crazy. Why would you ask that? Can't you see them both right now, okay, Steve?
I can't.
Okay, well,
I
they're
mean,
there.
I can.
You
They're
can.
there.
They're there.
They're totally there.
They're totally there. And so back to the points here as we graph these.
It's approximate. I mean, 69.2, where in the world is that? It's approximately, where the dot is.
Right. And you'll also notice with scatter plotting, it's all approximately. Even your calculators may or may not have a little bit of error in the line they give you if you compare it with a friend. Lines of best fit are approximations.
Yeah. They have like formulas and stuff to come up with them though.
They do,
So,
they do.
So if you put in the exact same data in two different calculators,
Should match.
It should match.
Should match.
Because there's formulas and stuff. We're not going to talk about how to find those formulas because that's unpleasant, I feel like, to find an actual line of best fit. If I had to guess, having taken a stats course last semester, I would guess that would be unpleasant.
So I don't understand anything Ms. Stevenson just said because I'm putting mine on a calculator. Blah, blah, blah. Figured out myself. I don't know.
Okay, well, the calculator told us that the regression model for the data is y equals 0.122x plus 31.23. That's awkward that we didn't round to the same decimal place. I wonder what happened there.
We rounded to hundredths
But then there were thousands, there's two different roundings going on.
because that's what cool people
Let's
do.
talk about what's going on though.
So now we want to find what the price would be at 200 million subscribers
Subscribers was X, so we put in the 200 for X.
because we know that.
We know it. We want to know about 200 subscribers. So we plugged it in. We're working out the math right now. And so we end up with Y, which is the average local monthly bill, being 55.63